Hello guys, and today we're going to be looking at physics kinematics. Okay, so one of the first things we need to know when we're talking about kinematics in physics is going to be displacement. Displacement is a very important concept when we're talking about kinematics. So displacement here represents, in kinematics, it represents a change in x. Okay, so we know that displacement is a vector quantity, which means that it cares about magnitude and direction. Okay, so just understand that displacement is the change in x. Okay, now we also need to take a look at velocity. So velocity is simple. It's just how fast an object moves. So velocity is also a vector quantity. But let's write it as how fast an object moves. It's also a vector. Okay, so how fast an object changes position. So like in the position versus time graph, we can find velocity because it's the change in position over time. Velocity is just the change in displacement, so the change in x over time. So really just understand that. Velocity is change in x over time. Okay? Now we need to understand time. Time we usually, in kinematics, we usually measure it in seconds. It could be hours or minutes, but usually you have it in seconds. Usually if you have hours or minutes, you probably need to convert it into seconds. But you know, for now, we're gonna use seconds, okay? So now guys, let's really just take a look here at some kinematic equations. These are equations or formulas, whatever you want to call them. But these kinematic equations are going to allow us to solve kinematic problems. Okay, so this could be a projectile motion problem, this could be a free fall problem, or any problem that includes velocity and displacement. So yeah, okay, so let's first start with the first equation here. Our first equation is going to be the displacement equation. So this equation is going to give us displacement. Whenever you see a v and an I, that simply means that it's velocity initial. When you see a v and an f, that just means velocity final. And of course, change in x is displacement. You could also see this written as d, but usually it's going to be change in x. So then you multiply the velocity initial times the time, and then you add this to 1/2 acceleration times time squared. Okay, for free fall problems, we will not need this part right here. This part for free fall problems is not needed because for free fall problems, we're going to have the object at rest and it's just falling down. So if the object is at rest, then its initial velocity is always going to be 0. And 0 times whatever number time is, it's just going to be 0. So we don't need this part. For free fall problems, we will only need the 1/2 times a times t squared. So let's take a look at another equation. So another equation you may see and you may want to use is velocity final equals velocity initial plus acceleration times time. So this equation is used to find velocity final. Of course, when we're solving equations, you could always have a velocity final, but you're trying to solve for velocity initial. Of course, we're going to be using this like that. So it's not like we're exactly solving for velocity final. We may be solving for acceleration or time or velocity initial. Number 3 is going to be this one, velocity final squared equals velocity initial squared plus 2a times the displacement, which is the change in x. So you would use this equation when you don't know what the time is. And this equation you would use it to to find any of these values here, but you would use it when you have time, or but if you're trying to find velocity final but you don't have the time, you would want to use this equation because it has the change in x. Okay guys, so we have a problem here, and it says the car accelerates 4 meters per second squared to 60 meters per second in 10 seconds. How fast was the car going before it accelerated, or before acceleration? Okay, so one of the things we need to understand is that velocity is measured in meters per second. Acceleration is measured in meters per second squared. Okay, because acceleration is just the change. Acceleration is the change in velocity over time. Okay, so that means that it's going to be meters per second squared. Okay, just don't worry about that now, but just really keep that in the back of your brain. Okay, so these are the units that we're going to measure these things, right? So, all right. So, if a car is accelerating at 4 meters per second squared to a final velocity of 60 meters per second in 10 seconds, well, what equation are we going to use for this? Well, we have to find out our variables, right? So we know that our acceleration is going to be 4 meters per second squared, because it says it accelerates 4 meters per second squared, right? And then it's accelerating to 60 meters per second. So our velocity final is going to be 60 meters per second, because that's the last velocity we know. Our time is going to be 10 seconds, because it did all this in 10 seconds. And what the question is asking us is, how fast was the car going before acceleration? So what was the speed of the car before? What was the speed of the car before all of this happened? What was the initial velocity of this car before it decided to accelerate? Well, that's what we don't know, right? We don't know the initial velocity. So which equation from the last part can we use to find this out? Well, we can use this equation. This equation has all the variables we need. Of course, we're trying to find the velocity initial, and that's what we're going to do. So we're going to plug in the velocity final, which is 60, equals velocity initial, which we don't know, plus acceleration, which is 4, times the time, which is 10. So we simplify this further. We get 40 plus velocity initial equals 60. Now we just solve this like a simple equation. We subtract 40 on both sides. And we're left with 20 meters per second as the initial velocity. Alright guys, so let's take a look at example number 2. So in example number 2 we have an object that starts at rest and then accelerates. So if the object travels at 40 meters to end up going 20 meters per second, what was its acceleration? So the object traveled a distance of 40 meters. So that's going to be the distance, or as we may call it, the displacement. Okay, so first of all, let's list out our variables. So we have the displacement, which is a change in x, which is 40. And then it says that it travels 40 meters to end up going 20 meters per second. So that means that our final velocity is going to be 20 meters per second because it says end up going. So at the end, it ended up going at 20 meters per second. And then we're just trying to find the acceleration, right? But it says the object starts at rest. So that means that the initial velocity, since the object was starting at rest, the initial velocity is 0. Alright, so we're trying to find the acceleration. That's what we're trying to find here. And we also don't know the time, so we cannot use one of the kinematic equations that have time in it to solve for acceleration. So we have to use one that doesn't require time to solve. So you guys can take a little try and pause the video if you guys want to proceed. Okay, so what kinematic equation may we want to use to solve for acceleration, but we don't have time? So what equation would we use to solve for acceleration without needing to have time? Well, we would use this equation. Okay, so this equation has Vf squared equals Vi squared plus 2 times acceleration times displacement. So this one, instead of using time, this one's using displacement, okay? So if you have a certain kinematic situation where you don't have time, you would want to use this one, because this one, you just use displacement. Of course, if you have displacement too, like you might not have displacement, you might have to do some other stuff, but yeah. All right, so the velocity final, we know that it's going to be 20, so it's going to be 20 squared, and then the velocity initial is 0, so it's going to be 0 squared plus 2, and the acceleration is, well, we don't know the acceleration, times the displacement, which is 40. So we multiply, since we can't multiply by this, we're going to have, this is of course going to be 0, and then plus, this is going to be 80a, so we have 400, because 20 squared is 400, and then 88 divided by 80, and that's going to give us an acceleration of 5 meters per second squared. Okay guys, so let's now take a look at problem 3. Okay, so you guys can solve this one by yourselves if you please. Okay, so let's see here. So we have problem 3 here, which says an object moving at 2 meters per second experiences an acceleration of 3 meters per second squared for 8 seconds. How did it move in that time? So let's list out our variables. And we have an object that is moving at 2 meters per second. So when you have an object that's moving at 2 meters per second already, that means that the initial velocity for the object is going to be at, it's going to be 2. Okay? So it says that it's experiencing an acceleration of 3 meters per second squared. So that means that the acceleration is going to be 3. Then it says that it does this for 8 seconds. So that means that the time in which this object was moving was 8 seconds. So how did it move, or how far did it move in that time? Okay, so when they're asking how far, they're just asking for the distance or the displacement, right? So we're trying to find here the change of x, which is the displacement. So that's what we're trying to find right here. So what equation may we want to use if we're trying to find displacement? Well, we want to use the displacement equation, the displacement kinematic equation, which is going to be the change in x equals velocity initial times time plus 1/2 times acceleration times time squared. Okay, so this is the equation we want to use. So, alright, so let's do change in x equals the velocity initial in this one is 2. So we have 2 here, and the time was 8 seconds plus 1/2 times the acceleration, which was 3, and then we have 8 as the time squared. Yeah, that's 64. That's times 3, 1/2, and then 16 here, and that's going to make us have the displacement, right? So now we just have to multiply the 3 times the 64, which is going to be, I believe, is going to be 3 times 64. It's going to be 192. So that's 192 times 1/2, which gives you 96 plus 16. And that's going to give you a displacement of 112. So it's going to be 112 meters. So this object traveled 112 meters when it accelerated from 2 meters per second at 3 meters per second squared for 8 seconds. So the answer would be 112 meters for displacement. Alright guys, this is going to be it. This is the end of the video, so thank you guys for watching. Make sure to leave a comment, if I made any mistakes, some feedback, and make sure to like and subscribe. Thank you for watching, guys.